Hi there. Hope you have a fantastic day today. This lesson, I will go through 2023 HSC paper with you. Of course, there's a PDF file versions on the description below for you to download so you can work with me. Otherwise, let's go straight into it. Question 29. We need to find the mode of x. So mode is the x value that gives the maximum value of f of x, the probability density functions, if you like. So to work out the maximum value of f of x, so f dash x must equal to 0. So let me just write f of x down first. So this is f of x here. Of course, we can use product rules, but easier if I expand it first, okay? So that 12x squared times 1 is 12x squared. So let me just write this down. F of x is 12x squared, and then 12x squared times negative x is minus 12x to the power of 3. Now to find the maximum value of f of x, so we f dash x first. So f dash x, so that will give me 24x minus 36x squared. So f dash x equals 0. So this means that 24x minus 36x squared is 0. So we just need to solve for this. So the common factor is 12x. So the common factor is 12x. I take it out. So 24x divided by 12x is 2. And 36 divided by 12 is 3. And x squared divided by x is x equal to 0. So therefore, x is 0 or x is 2/3. And we know that f of 0 will give me 0 anyway. Of course, we can ignore that one. So we just need to show maximum at x equal to 2/3. So now let's test it. So let me just second derivative of this first. So f double dash. So that will give me, so we just differentiate this. So that will give me 24 minus 72x. So f double dash, I can just put 0 there, will give me 24 anyway. So less than 0, so therefore minimum, okay, at x is 0. And then f double dash 2/3. So that will give me 24 minus 72 times 2/3. So that will give me, so just go 24 minus 72 brackets 2/3. There you go, negative 24. So that means less than 0. So therefore maximum at x is 2/3. And we know that when x is 1, f of 1 is 0 as well. So you can see that is maximum f of x is when x is equal to 2/3. So therefore, so there you go. X is equal to 2/3 is the mode. Part B. So we need to find the cumulative distributions for this probability density function here. So cumulative distributions is the integrations of this from a to b. A is 0, b is x, okay, from 0 to x. So let me just write this down. So cumulative distributions is equal to integrations from the smallest value, that is 0 here, to x. And then f of x is this, the small f of x. So 12x squared minus 12x power 3 dx. So now we'll just integrate this. That will give me 12x power 3 divided by 3 with minus 12x power 4 divided by 4. So that from 0 to x. So that will give me equal to, so I just simplify this first. So that give me 4 and that give me 3. So that will give me 4x to the power 3 minus 3x to the power 4 from 0 to x. So now we just substitute x and a 0 in the functions. So that will give me, so x is replaced with x, so that still give me 4x to the power 3 minus 3x become x as well, so power 4. And then we minus, so replace 0 with x, so that means 4 times 0 power 3 give me 0, and 3 times 4 power 0 also 0. So we just minus 0. So that will give me 4x to the power 3 minus 3x to the power 4. So there you go. Let me just rewrite this. So therefore, the cumulative distributions functions is this. 4x to the power 3 minus 3x to the power 4. So there you go. Part C. Without calculating the median, show that the mode is greater than the median. So to do this, so what we need to do is we just need to find the probability of x that is less than the mode first. So that is less than 2/3. So it should give us greater than 0.5 because 0.5 is the median. Remember that, okay? So now just to work this out. So probability of x that is less than the mode that is 2/3, which is equal to capital F of 2/3. So that will give me, so I just substitute into this function here. So 4 2/3 over 3 minus 3 2/3 power 4. That will give me, so I just go 4 fractions 2/3 power of 3, and then we minus 3 bracket 2/3 power 4. So there you go. 16 over 27. So you will press SD. So give me 0.59 and so on. Just round up to 2 decimal places we do. So 0.59. So that is greater than 0.5. So that is greater than 0.5. That's the median. So it's greater than the median. So therefore, so there you go. Question 30. So we need to find the coordinate of the stationary points, and we do not have to check the nature. So we just need to find the coordinate of stationary points. So in other words, f dash x is equal to 0, and we just solve for it, okay? So f dash x is equal to, we use product rules. So we differentiate the first functions. So if y is e to the fx, y dash must be f dash x e to the f of x. So if I differentiate this, give me -1. So -1 times e to the negative x is negative e to the negative x. And times by the second functions, that is sine x. And then we add, differentiate the second function. So we differentiate sine, give me cos. So cos of x. And we time by the first function. So let me just bracket this. It's easy to see, that's all. So there you go. So what I do now is I take out common factor. So the common factor is, I can see e to the negative x, okay? That is the common factor. So let me just take it out. So that give me e to the negative x brackets. So negative sine x plus cos of x. So now f dash x is equal to 0. So f dash x is 0. So this means that e to the negative x and negative sine x plus cos x is 0. Of course, you can write cos x minus sine x It's actually easier, but doesn't really matter, okay? We just solve it, that's all. So now that means e to the negative x is equal to 0, or negative sine x plus cos x is 0. So what I do, we know that e to the negative x is never equal to 0. So this means that no solution for this one, no solutions. And for this, I can just quickly move the negative sine x on that side. So that becomes cos x is equal to sine x. If I divide by both sides by cos x, so that means 1 is equal to sine x over cos x will give me tan of x. So tan of x. So now we just need to solve tan of x is equal to 1 within this domain here. Okay, keep that in mind. So this means that inverse tan 1 is power 4. So the reference angle is power 4, but it's in this quadrant here. So it's first quadrant and third quadrant because tan is positive. So inverse tan 1 is pi over 4 and power 4. So that's a reference angle. So therefore, the answer is x is equal to, the first answer is from here, go to this. So that is power 4. And then the next one is from here to here, give me 5 power 4. Because 1 plus a quarter, so 5 over 4. So that becomes 5 pi over 4. Then we have the x coordinate. Now we need to find the y coordinate. So we don't have to test for the nature. Remember that. That's not required by the questions. So now we just have to find f of pi over 4. So that becomes, so I just substitute into this function here. So e to the negative x become e to the negative pi over 4. And then size pi over 4. So that will give me, and don't forget, sine pi over 4 is 1 over root 2. So that will give me 1 over root 2. So e to the negative pi over 4 times by 1 over root 2. So what I do, I can just bring the negative index, bring it down, become positive. It's easier. Of course, you can just put in a calculator, give you a decimal point. Doesn't really matter. So it's just for me, need to just bring it down. So that become 1 over square root of 2 e to the pi over 4. So therefore, pi over 4 and 1 over root 2 e to the pi over 4. That is one coordinate of stationary point. And we find the second one. So f of 5 pi over 4. So that becomes, so e to the negative x, it becomes e to the negative 5 pi over 4. Sine of x, x is 5 pi over 4. And don't forget, sine 5 pi over 4 is equal to negative sine pi over 4 because on the third quadrant. So this is just like this, okay? E to negative 5 pi over 4 and negative sine pi over 4. So the answer is e to the negative 5 pi over 4 and times by negative 1 over root 2. So keep that in mind. So now I just simplify this. Again, I bring this negative index down, become positive. So that will give me 1 over, so this is negative 1 by the way, and then root 2 e to the 5 pi over 4. So now, so therefore, the other point is this 5 pi over 4 and negative 1 over square root of 2 e to the 5 pi over 4. So keep that in mind. Of course, you can just put on a calculator, give you decimal point, and the coordinate of stationary point is these two here. Okay, so keep that in mind. Part B, without using any further calculus, so we need to get the functions. So we need to show x-intercepts, y-intercepts, and the stationary points. So the station point, let me just write down the functions first, okay? F of x is e to the negative x psi of x. So for x-intercept, that is when y equals 0, okay? So when y equals 0, so f of x 0, so that means 0 equal e to negative x psi of x. So this means that e to the negative x is 0, psi of x is 0. So no solution for this. So then when psi x equals 0, that means x must be equal to 0, pi, 2 pi, and so on. But we only draw within this domain. So we just stop there. Okay, so these are the x-intercept. And let me just label this first. Scale it. So this is 2 pi. Half of this will give me pi. And half of this is pi over 2. And then 1 over 2, 2 over 2. This is 3 over 2. And we have the stationary points are this. Okay, so let me just write it down here. So pi over 4. So this is 1 over 4. That is pi over 4. 2 pi over 4. 3 pi over 4. 4 pi over 4. 5 pi over 4. So this is 5 pi over 4. And for pi over 4 is up here somewhere. So for pi over 4, that will give me 1 over square root of 2 e to the pi over 4. So that is the first stationary point. And the other one is 5 pi over 4 negative. Let me write here first, roughly. So 5 pi over 4, that give me negative 1 over square root of 2 e to the 5 pi over 4. And there you go. So now let me just connect these points together because x-intercept and y-intercept is at 0, 0. So now we just join them up. So there you go. And thank you so much for watching. Bye.